Jai Hind students, in the previous session what we have discussed was combination or the propagation of errors. In that episode we have discussed three articles: the result involving the addition of two measured quantities, the result involving the difference of the two measured quantities, and then the third article was the propagation of error was studied when the result involves the product of two measured quantities, right? So let's start with the fourth article. Fourth article is when the result involves the quotient of measured quantities, quotient of two measured quantities. Like x is the result and suppose a and b are the measured quantities. Then we are discussing this particular case. Let x is equal to a divided by b. So we are dealing with the division of two measured quantities. That is the quotient of the two measured quantities, which in this case is a and b. X is the result. Now students, as we have discussed already, let del x, del a and del b be the absolute errors in the measurement of x, a and b respectively, right? So what we are assuming is del x, del a and del b be the absolute errors in the measurement of x, a and b respectively. So therefore, equation 1 can be written in terms of the absolute errors. So when we write x in terms of absolute errors, it can be written as x plus minus del x, right? A, in terms of absolute error, a will be represented as a plus minus del a. Del b is the absolute error in the measured value b. So b in terms of absolute error will be written as b plus minus del b. Now let's solve it and try to rearrange the terms. What do we get is x plus minus del x. It would be equal to a can be taken as common over here. So we get 1 plus minus del a by a. And in the denominator b can be taken as common. So we can write 1 plus minus del b by b. Now look, a by b. From equation 1, a by b is x. So in place of a by b, we can write it as x. And still further, we can write it as x plus minus del x divided by x. This can be taken over here. So it can be written as 1 plus minus del a by a and 1 plus minus del b over b inverse, that is raised to power minus 1. We can easily write it like this. Still further, it can be written as 1 plus minus del x by x. It would be equal to 1 plus minus del a by a. Now, in order to expand this, you need to know about binomial theorem. This we'll do in the mathematical tools, but here I'll brief you about this particular topic, binomial theorem. What the theorem states is, if it's in the form of this 1 plus x to the power n, where the mod of x, it should be less than 1. X should be less than 1. And n can be any number. It can be an integer, positive, negative, or it can be even in fraction. So the series is 1 plus mx plus m minus 1 by 2 factorial, this is factorial, into x square plus terms containing higher powers of x, right? This is 2 factorial. 2 factorial is 2 into 1, that is 2. 3 factorial is 3 into 2 into 1, that is 6. 4 factorial is 4 into 3 into 2 into 1, that is 24, and so on, right? Anyway, we'll discuss this topic in mathematical tools. Right now you need to know that If x is small, then the terms containing higher powers of x can be neglected. I have already told you, del A, del B, they're very, very small. So the higher powers, del A to the power square, del B whole square, del A whole cube, all the terms involving higher powers of del A or del B can be neglected. Because the product of two small numbers would be still smaller and it will approach to 0. So that can be neglected. So from physics point of view, we neglect all the terms containing higher powers. All these terms containing higher powers of x can be neglected. Again I repeat, x should be very, very less than 1. Right? It is only then that it can be expanded using binomial theorem. Right? And also from physics point of view, the terms containing higher powers of x can be neglected. So, from physics point of view, we can write it as 1 plus mx. So, the terms containing higher powers of x can be neglected as they will approach to 0. Right? So this is the formula which we will be using over here. Please, from physics point of view, do note down this particular formula. Right? In mathematics, if you are a non-medical student, then in mathematics you will encounter an entire chapter devoted to this particular topic of binomial theorem. But from physics point of view, always remember, when this x is less than 1, then the terms containing higher powers of x, x square, x cube, x to the power 4. So all the terms containing these higher powers of x are very, very small and hence logically they can be neglected. So the first two terms are to be considered, right? In case it is minus over here, minus n, then it would have been 1 minus mx, right? Only the first two terms are to be considered. So this can be expanded using this, isn't it? Here it's in the standard form. Here x is equal to del b by b. Look, del b is the absolute error and b is the real value, true value, del b is the absolute error. So del b is less than b. Therefore del b divided by b would be less than 1. So it is satisfying this condition. In place of x it is del b by b and which is less than 1. So we can expand it binomially, isn't it? Here n is equal to minus 1. So let's consider first two terms. So it is 1 plus mx plus mx. M over here is minus 1 into x is del b over b plus minus this plus higher powers that can be neglected plus terms containing higher powers of del b by b and that can be neglected. Right? So only these two terms are to be considered. So what we get is 1 plus minus del x by x is equal to 1 plus minus del a by a multiplied by 1 over here. Plus minus is minus, minus is plus del b by. So higher powers of del b by b can be neglected. Right? Let's proceed further. So on further solving it, or further evaluating it, what we get is 1 plus minus del x by x is equal to, just open the bracket and do as the normal calculations. So 1 plus minus del a by a, then minus plus del b by b, then product of these two terms. Plus minus 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 plus minus. So it will be minus del a del b divided by ab. So on opening the bracket, you will get those four terms. Again students, this term involves the product of two extremely small quantities. Therefore, the numerator will approach to 0. Therefore, this term again logically can be neglected. Del A is very small, del B is very small. The product of del A and del B would be still smaller. And as a result, it will approach to 0. Therefore, this term can again be neglected. 1 get cancelled. So, plus minus del x by x is equal to plus minus del A by A minus plus del B by B. So, right hand side, there are four possibilities. Plus del A by A, plus del B by B, plus del A by A, minus del B by B, minus del A by A, plus del B by B, or minus del A by A, minus del B by B. There are four possibilities. Which one is to be considered? Yes, you are correct. This is the fourth time I am telling you. While dealing with errors, we always consider maximum permissible error. I have told you the logic behind this as well, right? So, we will consider maximum permissible error. So, taking maximum permissible error, what you get is del x by x is equal to del A by A plus del B by B. So, this is the conclusion. So, maximum relative error in x is equal to maximum relative error in A plus, this is the fractional or relative error, maximum relative error in B. So, that's the conclusion. So, students, just recap the third article, previous article. The conclusion is same. So, what I mean to say is that whether the result involves the addition of two measured quantities or the result involves subtraction of two measured quantities, the errors are propagated in the same manner. Similarly, if the result involves the product of two measured quantities or it involves the quotient of two measured quantities, the method by which we try to combine the errors remain same. For multiplication and for quotient, it is same. That is, the maximum relative error in the result is given by the sum of the maximum relative error in the measured values, right? So again, it can be further modified in this particular manner. I mean, we can multiply both the sides by 100. So the result can also be expressed in terms of percentage error. So let's check it out. So what to do is, let us assume this to be represented like this. We multiply both the sides by 100. So it will be del A by A multiplied by 100 plus del B by B multiplied by 100. This is, student, the maximum percentage error in X. It is the maximum percentage error in A, and this is the maximum percentage error in B. So that's the result. So whenever the result involves either the product of two measured quantities or the quotient of two measured quantities, the maximum percentage error in the result is given by the sum of the maximum percentage errors in A and B. So that's the conclusion. This is the conclusion. Okay, before proceeding with the fifth article, let's try numerical based on this, right? Let us do it. So suppose the density of a body is measured to be 10 plus minus 0.1 kg per meter cube. Suppose the density of a body is given by this, right? And suppose the mass is given to be, mass of a body is, suppose it is measured to be suppose it is 5 plus minus 0.1 kg, right? So, we are dealing with a numerical where the density is measured to be 10 plus minus 0.1 kg per meter cube, it's an SI, and the mass of the body measured by an instrument is 5 plus minus 0.1 kg, right? We are supposed to find out the volume of the given body, and we are also supposed to express the result in terms of both absolute error and in terms of percentage error, right? So let's proceed. How to do is, we'll consider the true value as well as the errors separately. Let's find out the true value. What's the formula basically? Mass is equal to volume into density. This is the formula. We need to find out the volume. So volume would be equal to mass divided by density. Right? So this is the formula. M divided by rho. Now look, it is in the same form. V is the volume result and these are the two measured values. So the result is given by the quotient of these two measured values, isn't it? So let's find its true value. What is the mass? What is the true value of mass? It is 5. What is the true value of density? It is 10. So it will be equal to 0.5 and in SI it will be meter cube. That's clear? So the volume would be 0.5 meter cube. This is the true value of the volume. Now, let's try to find out the absolute error in volume. So whenever the result involves the quotient of two measured quantities, then this is how the errors are propagated. This is how the errors are propagated. So using the same logic, over here what you get is del V by V. This is the relative error, maximum relative error in the result. It will be equal to sum of the maximum relative errors in mass and density. So relative error in mass would be del M by N and relative error, maximum relative error in the density would be del rho by rho, using the same concept. Just now we have proved it, right? So let's substitute the value. Del V divided by V is 0.5 or half. Del M, this is 0.1. It is the absolute error in mass, which is 0.1. True value of mass, it is 5. Plus del rho, absolute error in the density, it's again 0.1. True value of the density, it is 10. So it can be written as del V by 0.5 is equal to 1 by 50 plus 1 by 100. Right? So del V, it is half, isn't it? So it will be equal to 1 by 100 plus 1 by 200. After solving it, 0.5 cross multiply and then we'll get this result, right? So what do we get is, take LCM, 200 will be LCM, 2 plus 1, that is 3 by 200, isn't it? We'll get 3 by 200. So it can also be written as 0.00, it can be done like this. It can be written as 10 raised to the minus 2 and 1.5. So it will be equal to 0.015. This is the absolute error in the measurement of the volume. Is it clear? This is the absolute error in the measurement of volume. So students, how to express the volume in terms of absolute error then? So what will be the result? Result would be, volume would be in terms of absolute error. It is 0.5 plus minus, what is the absolute error? 0.015 centimeter cube. So SI unit is meter cube. This is the result. This is the actual result, right? And you can find out the percentage error as well. In case you wish to find the percentage error, that is del V divided by V multiplied by 100. It can be easily solved. What is the absolute error in the result? Del V, that is 0.015. What is the volume true value? That is 0.5 multiplied by 100. So it can be easily solved. So students, this is case 4, when the result involves the quotient of two measured quantities. So this is how the errors are propagated for the quotient of two measured quantities. Look, the result is same as was obtained in the case of multiplication, the product of measured quantities. So in addition and subtraction, the errors are propagated in the same manner. While in multiplication, that is product and quotient, the errors are propagated in this manner. Right? Okay, let's deal with the fifth case, right? When the result involves the power of a measured quantity. So the fifth article is when the result involves the power of a measured quantity. Again, we'll consider x to be the result, right? And suppose A is the measured value. So we are dealing with the case whereby the result involves the power of a measured quantity. So let us consider earlier we have considered the quotient case, when now in fifth case we are dealing with the case when the result involves the power of a measured quantity. So it is like this, a to the power n. n is power to this measured quantity which is a, right? Put this as equation 1. Now students, look, this is for the fifth time we are doing, right, in the same manner. So what I need to do is that a is the measured quantity, let its absolute error be del a. X is the result, let its absolute error be del x. So what is the proper way of writing the result x in terms of its absolute error? It can be written as x plus minus del x. What is the proper way of writing this measured value a in terms of its absolute error? It will be a plus minus del a. Am I clear? Now let's solve it. So what we get is x plus minus del x will be equal to a to the power n, that can be taken as common, so we will be left with 1 plus minus del a by a to the power m, isn't it? So am, it's equal to x from equation 1. And students, this can be expanded using binomial theorem, right? Binomially we can easily expand it. So since del a is less than a, therefore del a by a is less than 1. Therefore, we can make use of this series 1 plus x to the power m is equal to 1 plus mx. This is the condition. And as I told you, there are still several terms, right? But all those terms containing higher powers of x can be neglected. These are the first two terms. The third term will contain x square. Fourth term will contain x to the power cube. So all those terms, successive terms, will contain higher powers of x. And since x is very small, therefore the higher powers of x will be still smaller and hence can be neglected. So from physics point of view, only the first two terms are to be considered. Right? So what do we do? Expand it. In this case, del a by a is equal to x, isn't it? So using this formula we get 1 plus minus mx, m times del a by a, plus higher powers, and they are neglected, right? So it can be written as x plus minus del x by x is equal to 1 plus minus m del a by a. Still further, we can rewrite in this particular manner. 1 plus minus m del a by a. 1 get cancelled. So what do we get? Plus minus del x by x is equal to plus minus m del a by a. Right? Now again students, concentrate on the fact which we have discussed. While expressing errors, we need to always consider maximum permissible error. While dealing with errors, we need to consider maximum permissible error. So, taking maximum permissible error, we get del x by x is equal to whatever the power is, m times the absolute error in the measured value. M is the power of this measured quantity, that is a, right? So this is the conclusion. So what's the conclusion? Whenever the result involves the power of a measured quantity, then the maximum relative error in the result is given by whatever be the power times, here power is m, so m times the maximum relative error in the measured value. Right? This is the conclusion. And as I have suggested, if you multiply it by 100, then the conclusion can be stated also in terms of percentage error. Right? So multiplying both the sides by 100, what you get is m del a by a multiplied by 100. So this is maximum percentage error in X is equal to power times m times maximum percentage error in A. So this is the conclusion, right? So this concludes Article 5. So what to do is, let's try a numerical. Let's try a numerical based on this. Let us consider a cube. Let us consider a cube whose size, it's a cube. Its side is suppose L, and its side is measured to be 10 plus minus 0.1 centimeter. Find out its volume and express the volume both in terms of absolute error as well as percentage error. Let's see. So student, again we need to divide it into two parts. True value is dealt separately and the errors are propagated separately, right? What's the formula for the volume of the cube? It is volume is side cube. This is the formula. So V is equal to side is L cube. So this numerical relates to this particular article, whereby the result involves some power of this measured value. Here the power is 3. Here the power is 3. Right? In the article we have considered the power to be m. So how the error gets propagated? Error will get propagated like this. Maximum relative error in the volume, it would be equal to power times. The power is 3. So here 3 times the maximum absolute error in the measured value, which in this case is length. So it would be del L by L. Clear, students? It's very simple. It's very, very simple. So let's find out the true value. Side is 10. So 10 to the power cube. So it will be 1000 centimeter cube. That's the true value. True value of volume of this cube under consideration is 1000 centimeter cube. Now let's find del V. Del V divided by true value of volume is 1000. It is equal to 3 times del L, the absolute error in the measurement of length. It is 0.1. True value of the length, that is 10. All in the same units. Let's solve it. Del V over 1000 is equal to 3 by 100. So del V, it would be equal to 30. Isn't it? Del V, it would be equal to 30. Therefore, volume of the cube will be represented by, volume of the cube, it will be represented by actual value, that is 1000, plus minus its absolute error, that is 30, and centimeter cube. Clear? This is the proper way of writing the result in terms of absolute error. Now students, if you wish to write this result in terms of percentage error, then how to proceed? Now percentage error would be del V by V multiplied by 100. So what would be the percentage error? Del V is 30. This is the percentage error, this is the true value. So del V, that is 30, divided by true value is 1000, multiplied by 100. So what do you get is 3%. Clear? So therefore, volume of the cube in terms of percentage error will be written as 1000 plus minus 3%. This is the answer, that is the volume of the given cube in terms of percentage error. So students, I hope this article is pretty clear. So what's the conclusion? Basically, again I repeat, in case of addition or subtraction, the maximum absolute error in the result is given by the sum of the maximum absolute error in the individual measurements. That is, look, first case, if x equals to a plus b, or if x is equal to a minus b.